Basically, yeah, it is testing, not tasting. If anyone thought it was, take the opportunity to leave now. I'm probably the last person on earth who should ever say anything about tasting. If you were here last year for Bob's fault finding thing, I was just sitting there, it's quite nice that one. Try this one, it's quite nice. Try this. No, really, don't drink.
Don't drink anymore. You will be ill.
Okay, we're going to cover the 3 basic tests that they do in wine work. 3 of the basic ones that you can do in winemaking. I'm a chemist by trade. It's my job. I'm supposed to know what I'm doing, but I was took a little bit of the 60s back into university when I went there, so some of it wasn't very well remembered. But what I'm hoping to cover today is going to be free sulfur dioxide testing. That's a bit different. Sulfite, as you put it into your wine, isn't what's actually functional in the wine to prevent oxidization. The sulfite sort of releases a gas, which you all come across when you open a container, the sulfur dioxide, and that's the actual active ingredient. So we're covering out a test for that. Malolactic fermentation testing, we'll have a look at that. It's different from the other tests, because the other tests will tell you how much you have. So the sulfite testing tells you the quantity of free sulfite, acid testing tells you the quantity of acid in it. MLF just tells you whether or not you've got malolactic fermentation that is either taking place or has taken place in your wine. You can, if you're psychotic, you can use it to get a titration, something you can titrate, but you'd have to be completely insane to do it. It would be awful. And acidity testing, which, to be honest, it's the only important one there. It's the only one that I think you really have to do, because I'm pretty certain no one in this room has done MLF or sulfite testing. Certainly not the additional oxidation method we could cover today. But you've all made good wines without having to do the other tests, but the acidity testing, you really need to get that tied down because it is vital to making good wine. The important thing for doing the test, these are all titrations, so you're measuring, basically taking an active ingredient which changes colour depending on the pH. So it's acidic, it's one colour, it's basic, it's another colour. But the real key to using it is to make sure you get the right one. Usually if you're buying a kit, you'll get the right one supplied with it, but there's always a chance that you're out of phenolphthalein from the acid test kit and you'll get stuff from sulfite after. It doesn't work. It won't ever work. You'll get massively, massively wrong answers. pH scale, that's word ripped straight off Wikipedia. Measure the concentration of hydrogen ions compared to distilled water. Basically, how acidic is it? If it's got a low pH, it's highly acidic. If it's got a high pH, it's either low acidity or it's going through the other side and it being basic, like caustic soda. It's just a number scale. Indicator dyes, as I said, it's just something that changes colour depending on what the pH is. There's heaps and heaps and heaps of them out there. Some will cover the right range, but they won't work with the chemicals you're working with, so you can't use them. Others, the range is completely out with what you're testing for. This is the main thing. I think Browland actually sell, hopefully this will get edited out because I'd like to shop there and not get barred, but I think they actually sell an SO2 test kit which they say can be used for testing the acidity of wine. It's not true, it doesn't work. You've got one, haven't you, Rob? Does it still use the green? It's a green indicator, I think, with it, is it?
Blue.
Blue. Okay.
I have actually brought it.
Have you?
Yeah.
I might have a look at that. Because the SO2 standard test kit, the next slide, has a different indicator. But the reason it won't work is because there's 2 types of acid, strong and weak. Basically, inorganic acid, fatty acid, sulfuric acid, hydrochloric, they're strong. It just means they're really powerful, as the name suggests. Organic acids such as wine acid, tartaric, malic, citric, lactic, lots of X there, they're weak. It basically means that for the same amount of acid, a weak acid will not be as acidic as a strong acid. So if you had like 1 million molecules of hydrochloric and 1 million molecules of tartaric, the hydrochloric is going to be far, far more acidic. When you neutralise a reaction and you're doing a titration, all the titrations we do for our testing, you're taking your acidic sample, you're putting in caustic soda, which is basic, and you're neutralising it. And it's the point of neutralisation is where you're testing to, and that gives you the answer you're looking for. If you titrate a strong against a strong, you get a pH of 7, bang on neutral, which is water. If you do a strong against a strong base, such as caustic, and titrate that against a weak acid, you actually wind up slightly further on and into 8.4 pH, and that's where phenolphthalein changes. If you look at the SO2 test indicator along, changes just below 6, that's not 7. So it doesn't kind of make sense that that's where you're looking for the change, but this changes before.
Graham, sorry. So if you get the right indicator,
Yeah.
it's just when the colour changes.
Yeah.
You don't need to worry about whether it's sort of strong or weak, so long as you're.
As long as you get the right, let's just sort of explain why.
Yeah, no, I was
you
just
pick the right
sure.
one. But as long as you get the right indicator, whether it's strong or weak, it doesn't matter. Phenolphthalein will work if it's tartaric. You're titrating against citric, acid mix, or wine. That'll all be covered because they all do it in roughly the right range.
Okay.
But what I'm going to show now is a graph. Does anyone use a pH meter when they're doing titrations? If you add small amounts of acid the base to your sample and you measure the pH, you get a graph that looks something like this. This is a strong acid, strong base. So this would be like the SO2 test. You get a graph like this, and the point that we're looking for is there. See where the 7 is? That's bang in the middle of that vertical section. So if you the SO2 test, remember I said change that acidity to 6. Well, the volume for the volume of acid where it's at pH 6 is exactly the same as when it's at 7, so it doesn't matter.
Did you just do that stance for us again, Greg?
Especially for you, Carl.
You'll try that tonight.
If we do that, well, if we do the phenolphthalein, that's at 8.4, which is again up here, but you're still in this vertical section, so it's okay. You can use it. If you look at a weak acid with a strong base, and this is what you get in your test kits, it's completely different. You start off, see, I said it was weaker. Starts off higher. Titrate again along, you get your little vertical section again, bang in the middle of there. That's the equivalence point, and that's the volume when everything's neutralised. If you look again, acidity scale on the side, 8.4, phenolphthalein will go run straight through that vertical section. If you try and use the SO2 test indicator, that's going to be way down before you're anywhere near that. It's completely useless for it.
So where's the point with the colour change in the moment that it gets onto the vertical?
No, as long as your colour change takes place in that vertical section,
Right.
it doesn't matter what indicator you're using, it'll work. If you're elsewhere from that,
Okay.
that's it. You're
Right.
You're as well guessing. Make up the numbers for all the good, completely inaccurate.
Are you taking questions?
Yes.
Having done the titration,
Yeah.
I can get it to work well in white wine.
Mhm.
It doesn't work in red wine because you can't see the colour change.
Yeah.
So I looked at using the pH meter to look for that vertical.
Yeah.
What are the potential reasons for that not seeing the swing? Because your pH changes rapidly there.
Yeah.
What's the issues there if you don't see the pH change?
If you don't see the pH change,
Yeah.
it means what you're putting in is out of date or it's gone off. Basically, if there's no change, if you're adding it in and there's no change, either what you're adding in is too weak.
So you've not got a strong enough difference between weak and strong, so it is actually.
If you're running do you make up your own mixtures for doing the acid testing? Or do you just-
I have that. I've got a tech college with a chemistry lab.
Okay. Well, the only reason it wouldn't change, if you're adding the stuff in and you're seeing no change to pH, either means that what you're using isn't strong enough, or there's just nothing in it you're putting in salt water. That's the only reason it wouldn't change.
But if you had loads of distilled water into your red, that would work anyway, wouldn't it? You'd
See the change then.
you'd see it and you'd be able to see the colour change.
Yeah.
For a colour change, but if you're purely looking at the pH numbers using a pH meter, is how you're talking about pH meter
Yeah.
going in. If you're not seeing the change, your solution isn't strong enough. The Richie's acid test kit's usually a 0.1 molar.
Yeah.
No, I'm using one molar.
That 1 molar solution, that's quite strong.
Yeah.
Yeah, you can cut that back, dilute back 10 to 1 and you'll get a better solution.
The reason I was using one molar was to get a bigger difference,
Yeah,
so that I can see the swing.
yeah. With the 1 molar stuff, when you're putting that in, the graph's compressed, so it's easier to overshoot. That's so you'll put it's very easy to put too much in.
Right. Then you wouldn't see it because it's right.
Yeah. The other thing with wine acids, that last slide was a bit of a lie in terms of testing against wine. If you do it in wine, it's a lot messier, but you're looking for the one at 8.4. Have you done wine and found it to be fairly simple using the pH meter? You get a fairly simple graph. The wine acids they've got different acidic sites on them. That assumes there's one acidic site. If you've got 2 acidic sites, they have different sort of rates at which they'll go at, and you'll see a little bumpy track riding at. If you're doing it with pH 1, you might not see. If you're doing it with 1 molar solution, you might just miss it straight away. If you cut it back, you might end up seeing those different things. But it's 8.4 because that's when all the acid that you can find in wine will be titrated, will be reacted at 8.4. There will be nothing else beyond that you'll see.
I found that the trouble I had using the pH meter was that my pH meter reacts too slow.
Yeah, they're a bit of a bugger for
I mean, I've got a better one on the bench there, but it's still slow.
Yeah,
to see
this
the
is.
change.
I've found a similar problem with digital things with doing temperature probes. Because I use a digital temperature probe on the mash, and it's reacting, and it can be slow, but it can be too quick as well, in a sense that the numbers are ticking through, and you think you've caught it, and still going through. Personally, I think that Richie's acid test kits, if you do them properly, you should be able to get good results with them every time. The big problem, I think, we've gone it now, main components of it, you've got your caustic solution, 0.1, and your phenolphthalein indicator. It does work. There's no doubt about it, it does work. Neutralising the acids with caustic will include any dissolved CO2, so make sure you've expelled all the CO2 before you do it, otherwise that'll contaminate your reading. It will artificially inflate the reading. It's easy enough to shake it, put it through a vacuum, make sure it's been degassed.
Do you do it in a jam jar as well?
Yeah, they give you that epoxy little
rubbish,
test tube. It's absolutely the wrong thing for this job. If you're trying to mix it and you're shaking it like that, you're going to get a lot of stuff happening on the top and nothing happening on the bottom. You'll get a little dead zone of no turbulence. And you can titrate and go, that's great, that's everything reacted. And then you mix it again and a whole bunch of new acids come in and it's changed the pH again. Or it's changed the apparent pH. There's the instructions, and if you've done them, you'll know them, but you measure out your volume of the acid. It's 5 mils for the Richies, I think. Dilute it back with 10 mils of distilled water. You're right enough though, you can dilute it back with a gallon if you felt so inclined. If you're doing red wines, the more you put in, the less of the red from the wine comes through, and the easier it is to see the colour change.
Would you recommend using Richies for red?
Yes, absolutely.
I'm overthinking this, I'm making it too hard.
You can go really far out. I'll cover it in a minute in the next slide, I think, but you can go really far out with the accuracy you're doing this, like 12 decimal places or whatever. But the Richie's, all acid test kits that we use, unless you separate each individual acid, make an assumption that they're all tartaric acid. So there's built into it a natural sort of inaccuracy, but it's not huge. But the Richie's ones are ideal for reds and whites, I think. I've not had any problems. I'm testing them, the results make sense, I've treated, and I've got a wine that's drinkable at the end of the day. Whether or not it was right, it's hard to say. It worked.
When you do it with the jam jar, you've got much more space and you can add much more distilled water.
Yeah.
It makes it so much easier.
Definitely, absolutely. Get a jam jar, do it in that. Save you a lot of hassle. Test tubes, you can do it, grow a very small plant, whatever. Just don't use it for the test, it's useless.
One crest.
The reason I think that the Richie's acid test kit, people don't think it'll work, is because red wine will change colour as the pH drops to 7. And they see that happen and they go, oh, it's reacted. It starts off red and then they get a sort of pinky blue colour and they think, well, that looks okay, it's changed colour, it must be that. But if you take wine and you neutralise it, it goes blue.
Yeah.
I'm not sure if it actually comes through in the colours of wine, but I reckon low acidity wines will appear purpler than higher acidity wines. I know nothing about wine, I'll be quite honest, but I do know about the test. That's my theory on the matter anyway, but you'll see it turn blue, that's not the end point, keep going, and then you'll see the pink colour come in from the phenolphthalein, and that's what you're looking for, but avoid the blue. Don't make the mistake of doing that because you're way off on that bottom part of the graph, that's where you are. You want to be further on and into pink. If it makes any, if you're not sure, just add more, because it'll only make it pinker. And if you're wrong about it being the end point initially, then you found the right end point. If you're right, you've not lost anything. You've lost maybe 5 mils of the test kit. Go back to Carol, buy another kit. I'm not sponsored by him, by the way, but I am absolutely convinced that these work perfectly well. I've had no problems, and I do think this is the most important test that you can do in your wine. There's conversions. I can print this out for people if they want. It just tells you how to convert it. You might want to use a larger volume of wine in your test. You can do it with 5. You might want to try it on a bigger scale. And this can take into that. Now, do the Richie's kits still say to do it in sulfuric acid? It converts out into sulfuric and then you convert it. Right. We've got an equation there that does it directly into tartaric. The reason why it's in sulfuric, and I will bet a penny to a pound that this is why it is because a chemist came up with it. And it's sensible for a chemist to do it to sulfuric acid, but for a winemaker, that's...
The French do it in sulfuric.
Yeah,
it's historical, I think you can find.
Yeah, it's because back in the day when it started, someone
was a chemist,
and they did it. Tartaric acid is a logical way for a winemaker to do it. So,
does it matter about the temperature of it? So if you've boiled off the CO2,
I would let it cool down. It will have an effect, but I mean, as long as you're around about room temperature, you'll be all right. It won't make a huge difference. But I'll post this on the forum so you can get the equations straight into it. You can do it with any volumes there. This is where we're going a bit crazy now. This is a free SO2 test. I don't know why, but these don't seem to be available in the UK.
There's a sulfur quick that Vigo do, which is stupidly expensive.
Is that the wee test cards?
No,
yeah.
No, it's a titration.
Is it?
It might be behind you to the right.
This one is the aeration oxidation method. There is another method called the Ripper method. It's suitable for white wines. Most of the governing bodies on winemaking do not recommend it for red wines because it's prone to inaccuracy. You add iodine to it and you monitor the colour change of the iodine in the red wine. You're kind of back into the situation with the Richie's test kit where it'll be confused. Apart from the iodine reacts with the tannins in the red wine and the polyphenols, and at that point you're back to guessing. You're as well not doing the test. Save your money, don't bother with it. This one, however, takes the sulfite out of the wine and does it somewhere else. Makes it a lot easier to get an accurate result. Components, indicator dye. I apologise, I have made some test kits for those who ask. We've got 6 kits, so hopefully there'll be enough for everyone. I couldn't find any small bottles at my work, so I've had to use White Labs yeast vials. So hopefully they'll be sufficient and they won't fall over in your car, because then it'll turn green and then red and green, depending on what you've been stepping in before you get into the car. 25% phosphoric acid, very corrosive, horrible stuff if you get on your hands. Take care of that if you're using it. 0.01 more caustic soda. That's 10 times more dilute than the stuff you get in the Richie's acid test kit. You can use this stuff in the Richie's acid test kit, but you'll be adding a hell of a lot, so you'll be adding 10 times as much. Where you can use the Richie's acid test kit in this, you'll be using 10 times less. So you can if you want to, I don't recommend it. And the 0.01 more hydrochloric acid. That's for treating the hydrogen peroxide, which I do not supply because you can get it in the shops yourselves. It goes out of date very quickly. 3 months is about the sort of recommended once it's open. Get the cheapest you can. They always have a stabilizer in it. Stabilizer in it. And that keeps the pH at a fixed number, and that stops it from reacting. Hydrogen peroxide is an oxidizer, bleach in here. By keeping the pH at a certain value, it doesn't spontaneously do it. But if you let a guy go outside those values, it starts to spontaneously react and oxidize itself essentially and turn it into water. That's why you've got the acid in there, the 0.01, because you use that to overcome the stabilisers that are in there. The equipment, now I've ripped this from, let's just go down. There's the equipment. That's something good. Right, what you've got in this one is on the left where the pump is, that's a cheap aquarium pump. Get the cheapest you can off eBay, it will work. I've not supplied any of the glassware because it's really expensive to get a hold of. And my lab would notice like 6 sets of everyone. You've got 2 of the little glass things over there, so 12 of them going missing tends to stick out. Whereas a couple hundred mils from a gallon drum of chemicals, it doesn't get noticed. You've got a magnetic stirrer in there, you don't need that. You've got a hose going from the pump up into the sample, which is the first bottle on the left. That's where your red wine is. Then another hose, the hose going in from the pump goes down into the sample, so it blows the air through the wine. The hose coming out of that one into the second bottle only goes into the top, so you're only getting the gas that's blown off from the wine getting blown into your trap SO2 one, which is on the right, and then that one's just open to the air to like the air escape. You've got the same thing though when it's coming in. It goes into the sample, bubbles it through that, and then any excess air is just expelled out. Right, this is where the chemistry actually comes into it. That Na2SO2O5, that's your sodium metabisulfite. If you put that into something with acid, even if you don't have acid in it, but if you put acid into it, it starts to back it off SO2, and that's your active ingredient in metabisulfite in your wine. That's what stops your oxidation. In your wine, obviously, you have some acid, so that drives it out. But it's not all being forced out, it exists in an equilibrium. So the rate at which it's being produced is the same as which has been reabsorbed back into the wine. You're looking confused there.
I'm just trying to think through what you're saying is.
Yeah, the metabisulfite, when it's dissolved in the water, at that pH, it will release a certain amount of SO2, but it will also absorb a certain amount of SO2, and it will do it until it reaches the equilibrium, where the rates of absorption and expulsion are balanced. If you start to remove the SO2 though, then it'll keep bucketing it out. So you can drive off all the stuff by removing SO2, and that's why eventually when you put your bisulfite into your wine, it can all become consumed. If it's all reacted, it'll keep punting it out until it runs out. So any oxygen that gets in gets consumed, and you wind up with no sulfite left, and your wine tastes vile.
Is it no sulfite or no free sulfite? So
there's the free sulfite is, I should actually have covered this function by now. Free sulfite, you'll see tests for total sulfite and free sulfite. The free sulfite includes any sulfite that's in the wine that's available to become sulfite that's gas or sulfur dioxide outside of the wine. When you add your sulfite, the sulfite will react with any of some chemicals in the wine, and that becomes consumed, and that's trapped, and that can't be used to prevent oxidation. And you can't drive it off, it means boiling your wine. So it's gone, it's ignored completely. So what we do in the test kit is we put a big dollop of non-phosphoric acid, the really concentrated stuff. Big dollop of that means that you start producing loads of the SO2, and you're driving that off into your other reaction vessel. You could leave it running normally without the acid in there, but it would take forever to do it because it's not very acidic. The more acidic it is, the further towards that side of the equation it goes. More acid drives it over here. Does that make sense?
yes.
That's what happens in your first little beaker. The second jar, you've got your hydrogen peroxide, which is a really powerful oxidizer. And the SO2 hits there, it reacts with anything. It's an oxidizer and forms sulfuric acid, which we can then titrate against. Right. The hydrogen peroxide is very, very powerful, so you can bubble it through at a hell of a rate and it will catch it. It will just bang, as soon as it sees one, it reacts, it's gone. Once you have the acid, we can titrate. However, titrating in the wine will interfere with the acid, so that is why we take it outside of the wine and do it in a separate reaction vessel. Just a quick guide. To be honest, if you're not going to do it, it's really limited in this. I've got instructions printed off the internet. This is the same as the more wine test kit. They're gracious enough to put exactly what they've got in the bottle. So I put exactly what they put in the bottle in those bottles. So I'm pretty confident their instructions will work. They don't trade in the UK, do they?
No.
There we go, it's not a problem, they won't mind, I'm sure.
I'll edit that out.
Sorry. Oh, this is why I was a bit worried about the video camera then. But yeah. Prepare your peroxide solution. I've got another slide on that, I think. Prepare the peroxide solution. Measure your wine sample in, add the acid, you acidify it, it will immediately start to back it off SO2. So you need to get that sealed, lid on, and then into your peroxide sample, and then set your test, run it. You need to run for about 15 minutes, 15 to 20 minutes I put it there. Turn off the pump, do your titration in the SO2 trap ball, and then fire the equation in and you'll get your ppm of sulfur dioxide. I'd like to be more specific on this. The brutal truth is I've never done it. I've taken what they've said to do. I'm assuming it works. Hopefully the people who are getting the kits will be able to tell me if it works. I trust that they'll have a go. I know I made heaps of the stuff for Bob, not realising quite what he was going to be doing with it. And he didn't have a chance to do it. It's one of these things, as I say, have you made good wine without doing it? Yes, but you need to do it. Not exactly, but if you want to keep a wine for 10 years, then yeah, you probably do want to know how much SO2 is.
Can you just tell me what the pump does again? Because
the pump bubbles air.
Confusion today.
The pump bubbles air through the wine sample, and that helps to push the gas out through and into your trapped SO2 bottle on the far right. It just carries it through.
Is that basically forcing oxidation?
No, the air is really just there to act as a carrier. It's just to get the SO2 pumped out of the bottle and into the next one. You could leave it and it would probably get there eventually, but you probably can't. You're saying about the forced oxidation, you will get there is an inaccuracy built into this because you're pumping air through. So obviously it will react, but it's compared to what it does from the hydrogen peroxide, it's nowhere near as quick.
Is that sucking or blowing?
It's blowing.
Right, okay. So those pumps Carl's got would be ideal for that then, wouldn't they?
Possibly, I don't know what volume they do.
Okay.
You're looking for about 3 litres per minute. Really, it's nothing fancy. I have got
Yeah, no, that'll do that.
lots of trips. That's one I got from eBay for £3. That'll work.
Yeah. What happens if they do more than 3 litres a minute? More
To be honest, you're likely, it depends on what size of holes you've got in to bubble through. If you get a back pressure, you can blow the tops off, and most of the chemicals we're using are okay. The phosphoric acid is evil stuff. If you get one of these kits and you never use it, keep it around because you can use it to clean stainless steel. It'll dissolve rust off anything, and it passivates it. Some of you in the engineering professions might have heard of navel jelly. This is navel jelly without navel jelly. Or without the jelly part, sorry.
I think John gave us that last night.
Oh, was that royal jelly?
No, sorry.
No, that was definitely navel jelly, I think.
Oh, it'll be like wine jelly next year.
If you've got any questions, I'll be happy to help answer them, because this one's a bit more tricky than the simple acid test. I'm quite happy to help. If we find out they work, then I can start looking at doing them on a sort of larger scale for people, and then I'll provide all the backup you need. I'm going to regret saying that, I suspect. I really hope they don't work now. Right, shot ball hydrogen peroxide. There's a trick to this, it's in the instructions with the kit, but basically it's stabilised at a certain pH. You need to get that pH back to 7, which is the neutral point of the acid of the test kit, and then you need to titrate it. It's basically a quick guide on how you do it, because it's slightly acidic. It might even be slightly basic, I can't remember, but you need to take it back and then take it back to the neutral point. You're looking very confused.
So if this is to replace the hydrogen peroxide because we've done so much.
Yeah.
We go and buy hydrogen peroxide. Is it stabilised? The stuff that we buy? Is that
It will be stabilised.
Right.
You don't want it. Some of them, it's for contact lenses.
Yeah.
You don't want anything fancy. You want to go into Asda, Morrison's, and buy their cheapest own brand products, or no other additives apart from stabiliser. You will always have stabiliser. And Some of them might stabilise at pH 7 depending on how they do it. In that case, your net results could be nothing because you can add a bit of acid to it and then that'll acidify it, but then you're going to take it and make it a bit more basic. But get the cheapest you can because that will work. And you don't have to get it from me because the stuff I've got is about 20% and it's been sitting in the fridge since before I was born, so I don't think it will work.
If you bulk buy it, you might get asked a few awkward questions.
Yeah, you don't want to. It doesn't keep. Once it's open, that's it. It's straight away. It's going to start reacting with the air in it, and if any air gets in, it's going to start going for that, and it's going to end up water. Basically, I mean, it reacts to form just water. So you don't want to bulk buy. You just want to get a little bottle, do your test, and that's it. Ready to move on? Fantastic. Yeah. We want to take this slide out. Like I say, I've got the instructions for more wine. Get the equipment from me, but you don't need lab grade equipment to do this. If you want to do it with jam jars and rubber bands, do it with jam jars and rubber bands. All it needs to be is airtight. That's the only requirement of your equipment. So long as the gas doesn't get out, it will work. And so long as it's glass. Plastics, I wouldn't recommend using. Malolactic fermentation. That is a My Little Pony. I warned you, I told you, Pete, that you'd have My Little Pony in the presentation for bringing up the song again.
Good stuff.
Hang on, that's an anime My Little Pony.
That's an awesome face My Little Pony. And it's an awesome face My Little Pony because malolactic fermentation test is awesome. It's got a really clever bit in it. And this is me geeking out as a chemist. It's got a really, really cunning trick in it. Good points of it, it's not a titration. No faffing around with burettes, taking careful measurements and stuff like that. It's relentingly awesome. It's always a good point. The chemicals are flammable, corrosive, and they honk. They're absolutely rancid. Game on. Same thing, it's disadvantages. It's not titration. It can't tell you how much lactic or malic acid you've got in there. It's awesome. You know, the same problems again, and it's flammable, corrosive, and sticky. If you do this in the kitchen and spill it, I'm taking no flack for that happening. Do it somewhere sensible. This is another Bodge from me, from Graham Cowie Laboratories, stolen from Oppen. I made this in my lunch break, by the way. So that was fun. I had my lunch away from the samples when I was making it. The solvent is flammable, corrosive, orange and sinks. It's not Bodge reason wine. Chromatography paper, and it is paper. It's probably fancy in some way, shape or form, but I'm absolutely convinced it's just coffee filter paper. If you run out of it, get some coffee filter paper. It will probably do the job okay. This isn't a massively accurate test. This isn't something that you can put numbers to. It's really quite crude, but it has a cool point in it. You need a nice big coffee jar to do it. That's about the only thing that you need to do and somewhere to do it. That's the length of the chromatography paper. You're meant to run it the full length of it, and it's going in vertically. Whether you do or you don't know. I've never done this test before. It's encouraging. I have absolute faith in the chemical. I've done one test on it, and it looked like it worked. But I had nothing to compare it against. So whether or not it was a malic dot, a lactic dot, or just something that had landed on the paper whilst I was setting up and coming down, I don't know. But it does seem to work.
So what you're saying is, trust me, I'm a chemist.
Yeah. There's, I'm sure there are famous last words from chemists. The guy who invented CFCs, he was also the guy who invented lead additives in petrol. So when I say trust me, I'm a chemist, don't think of him.
Sorry, so you're going to go through how you do that?
Yeah, I'll do it just now. Right, this is the theory, this is the boring bit. The mixture is dissolved in a fluid called a mobile phase, which carries it through a structure holding, can't read that, it's the crease, another material called the stationary phase. The various constituents of the mixture travel at different speeds, causing them to separate. Your mobile phase is the solvent, the stationary phase is the paper. And basically all that says is when the solvent wicks up the bit of paper, the malic acid will travel along with the solvent at a different speed as the lactic and the citric and the tartaric, and they all have their unique speed that they'll travel at. And it won't vary whether it's come from a red wine or a white wine. The speed of tartaric acid and the solvent will always be the same. The problem with this test is, again, we're using an indicator. The solvent in the test has the indicator in and it turns orange in the presence of acid. The indicator is orange in the solvent, which means the solvent's acidic. So how do you get to see where the dots are if everything's orange? Now this is the cool bit. Because it's flammable, it means that it's got a low boiling point, so it will evaporate off the bit of paper. When it evaporates off, the solvent changes, the indicator changes colour because there's no more acid where it's evaporated off. But where the wine acid is, it'll stay the same colour. So you wind up with the little dots on a big bluey green sheet of paper. That's so awesome. It's like developing a flow. That to me is just a really elegant solution to the problem. That's why I think it's unrelentingly awesome. Again though, if you're putting it up to dry to develop, do it somewhere else please, because it'll probably dissolve your worktop. This isn't nice. Put a tray under it, it won't eat through metal. It might, clean up metal. Make sure that we've got a nice shine on any rusty bits of steel you've got. It is an acid. It's not very strong. Well, it's weak in the sense that it's not very potent, but it's strong in the sense that it's quite concentrated. There's lots of it in there, so what it makes up in punch, it makes up with lots of little punches. But yeah, hang it up somewhere.
Sort of like a dwarf.
Yes. you've got all the punch of a full-grown human being in the space of the end of a ball pen hammer. It's going to hurt. Right, I've got pictures of this. Trying to explain it with words is difficult. When you see the pictures, you see how simple it is. You have to use a normal pencil because normal pencil isn't affected by the solvent. It won't get carried away. If you use a pen, the pen will get carried with the solvent and it'll affect the results. If you use a coloured pencil, such as a kids colouring inset, that will run as well because it's a wax that they have in there that gives it the colour, and that will certainly run with the solvent. So you take your paper, you draw a line 2 centimetres from the bottom, straight across there. You put some X's on it, spaced about 2 centimetres. You can do them closer together, but for reasons we'll see in a second, you might not want to. You get a capillary tube. I have brought some of them. It's basically a very, very, very small and narrow glass tube. The way they are when you get them, they've got something and it's a mil across the diameter of these tubes. That's too thick. To get this to work properly, you need to melt them in half, and then pull them apart, and you end up with a really long, hairy bit. And then you break that off so that you can still get into the tube from the bottom. I've got a heap of them with me, but you really, when you spot this on the paper, it'll flow out with a big dot. You don't want that. You want the smallest little dot of stuff. And the 1 mil, it just, and that's it. You've got something that big on a bit of paper, and you've got an X in the middle there, and you've got an X halfway through the blob. Doesn't really work. You let it dry and then you do it again, and you keep repeating it on that dot until you have a nice dark red colour on your dot. You need to make it dry because it's not dry. If you need to let it dry, sorry, so it's not dry. When you put the next batch of wine on, it'll push any previous wine that's still on there out further into the paper, and you get a huge big. You'll see the test. It makes it nice. Then you pour your solvent into a glass jar. You only need a little bit. It's the level of the solvent in the glass jar needs to be lower than the line on the bit of paper. If it's above it, the test won't work because all the acid in the wine will flow out to the bulk of the solvent. And you can reuse the solvent, by the way. That's another neat thing with this. Once you've done the test, pour the solvent back, unused solvent back in the jar. You can use it again. If it does go above the line, though, it's contaminated, and every test you do will have every acid that was in the wine tube tested. So you need to make sure that the thing is below. That's not showing up at all. I've got some pictures of this coming up, and I stole them off it. Didn't ask permission, but hopefully they won't mind. You lower your paper in and you leave it until the solvent reaches the top. And that's basically it. Once that's done, pull your bit of paper out, hang it up to dry, and once it changes colour, the bulk of the paper changes colour, that's the test finished. Take hours to do it. When I say several, I mean about 6 to 8 hours to do this, maybe even longer, depending on the paper you're using. There's a bit of paper. They've used double-sized bits. I couldn't get them, well I could, but they were twice the cost. And they get noticed when they go missing from the lab. These don't. Line across the
Well, I'm
bottom.
aware this will be on YouTube, Graham, aren't you?
It's alright. I didn't think about that actually. Can we edit that bit out?
I'll edit that bit out, yeah.
No, it's
Does
okay.
it want to start again?
They call me Marge sometimes at work because if you see me, I'm always in the lab. I'm always doing a homer.
That's made you superbly identifiable on YouTube. This is me and I'm called Marge.
Narrated. You've got the dots going across the bottom on your line, about 2 centimeters up. Each of those will be a different sample. The two at the left are controls. You might want to do this if you have any tartaric and malic acid kicking around, because for those, you know what they are, and however far out they go, you know anything on that level is the same as what your control was. That gives you a way of positively identifying the spots, and that's something I didn't have because I didn't have any tartaric acid. And somebody who, I'm not going to name Richie's name, was supposed to give me some so I could run the test, but he didn't quite get around to doing it.
Just a bit in solution.
Yep, that's it sitting in the jar. Lowered it in very carefully, try not to splash it. So
So it's just a little bit of tartaric or citric acid in solution.
just a little bit. You don't need much because you think the amount that you've got in your wine was about 3 to 4 grams per litre total acidity in wine.
Yeah, no more.
67.
67, sorry. Again, don't know much about wine. So you're looking at similar sort of levels. This will actually detect really, really low levels. So you don't need it to be that strong, but so it's a good gauge, and it'll keep forever. So every time you run one of these tests, go and get your sample out, dot, dot, dot.
But again, and that would just have to be a tiny dot. You'd only have to do that once, would you?
Yeah, I would do it a couple of times. You want to get as much of the stuff on there as possible.
Okay.
You can make up a really concentrated solution, but why would you want to in the case that you know that's wine that's going into a test, or that's acid going into a test, it's not going into wine.
Yeah.
Carol's wandering off in disgust because I'm trying to convince people not to use lots of acid.
Don't edit that bit out.
But you might not be able to see it, but just underneath the line you can see the top level of the solvent. That's about the level you're looking for. Just enough, and it'll wick up slowly over time. See the whole thing's orange. That's when you know that it's...
Can you just point it out with your fingers roughly where?
You're doing this
I'm not sure I'm looking at the right bit.
right there. Just, if you want to come around here, you'll see it on the screen. There
I
you
see,
go.
yeah, you can see.
Can you all see that there? You can see the level of the line is there, but the solvent only comes up halfway up.
Yeah.
That's the sort of level you're looking for.
I'll put that image in the
Yeah.
picture in picture.
And like I say, once this test is done, provided you've not splashed it onto where you're testing, you can reuse this stuff. It does go off a bit over time, but all it'll do is give you a smeared out result. Eventually, it'll turn into one big smear. You'll see the results just now, and it's useless. But up until that point, you can still use this very well to do the tests. Right, this is just more instructions, hang up to dry, yada yada yada. Already covered this. Well ventilated area, that's very important. This stuff is an acid that's airborne now when it's evaporating off. If you do this in an enclosed space, you might breathe it in and it might do you harm. Take care. These are chemicals, they should come with warnings, they do come with warnings. There are MSDS as a safety issue to tell you all the risks. But I really would not do this in an enclosed space. And there we have a completed test. Oh, here we have a completed test. Ooh. It's nice and colourful. You can't really see it on this, but at the top here is your lactic acid. It's very faint on this, probably because the guy used quite a dilute solution. But up here is where all the lactic acids are. And then along here, this is this control spot for malic acid. So you know anything with a dot here has got malic acid in it. And if you look very closely, I mean, you can have a look afterwards, you can see there's little dots here and on the other one, so you know there's still a malolactic fermentation. You've still got malic acid in there, therefore it's not all been converted into lactic acid. You know that it's not safe to bottle then, because if you do bottle it, it's still going to keep going and it's going to blow the cork out of your wine. Bottom row almost always is tartaric acid. You get some contamination and stuff here, you get the blue dots, that's just been taken up with the wine. But that's basically all the test does. and is. You can do a titration on this afterwards if you're, like I say, if you're psychotic. So what you need to do is cut it out with the little bits, and then get each little dot and dissolve that in solvent, and then titrate against that. And you can do it. They have chromatography columns, which is the same idea as this, but it's a tube full of material rather than a bit of paper. And you can watch them. You can do it with this one, obviously, because the whole thing's acidic. But in other cases, you can watch the little coloured bands come down, and you can just wait, and you know it's the third one. Take that sample off, and you know you've got your sample. Then you can do your titration. Very, very powerful technique. And that's it. And this is where I regret it. Any questions?
Was it just chance that the yellow dots were completely sort of different sizes, or is that?
Different concentrations, because when it takes it up, but it flows up, and it's like anything that flows, encounters different resistance. The paper is not completely uniform, so it'll spread out a little bit.
Yeah.
If it does just tell you if it's present or not in this case. The spot can kind of give you an indication that it's spread out. You might not see the yellowness in the paper, so it could be weak, or it could just be that it's spread out quite a bit.
Splendid.
Thank you.
Top stuff.
I'm glad no one asked any difficult questions.
I feel educated.
Yeah.
Very good. Yeah.
They're really scary. I actually did put a couple more slides in which had like proper chemical stuff in it. This is the thing I was saying that just a slight point was off the video.
Oh, yeah.
You mind I was saying that you can't just a limit to the accuracy in the wine. When you do the titration, you assume all the wine is tartaric acid when you're doing the acid testing. You assume it's all tartaric, or you assume it's all sulfuric. But it's not, it's a mixture of different acids. And what affects that is the weight, what affects the test, perceived strength in a test, is the weight of the acid and the photonicity, which is the number of acidic sites in the acid. If you look at citric acid, I keep wanting to point up there. It's got, wait a minute, can we use the mouse?
Yeah.
Yeah, it's got 3 acidic sites. There, there, and there. That one there isn't one. So only when you get that little bit there, that's an acidic site in the case of organic acids. And it's 192 grams. That's the weight of 1 mole. A mole is just a handy chemist's notation for a fixed number of molecules. The reason we use mole is because that fixed number is 6 times 10 to the power of 24 molecules. So it's an awful lot.
I'm now being reminded why.
Yes. But malic acid's 134 grams, it's got 2 acidic sites, and tartaric's 150 and got 2 acidic sites. So obviously if you've got a blend of these things in your wine, assuming they're 1 is going to be discounting the various different strengths that each one has. So there's a limit to how accurate the acid test kit, but for winemaking purposes, it's quite alright.
I mean, what we're talking about, say you've got like quite a citric acid would be elderberry wine,
If you
tartaric grape wine would it be?
If you're doing an acid wine that only has citric acid in, assume it's citric acid. It won't make a huge difference, but it could be the difference between it being a good wine and a bad wine potentially. I mean, I can sit there and work out how much an effect it would be, but if all the wine has in it is citric and all you're putting into it is citric, you're as well assuming that it's all citric just for the sake of that little bit of extra accuracy. It might be about half a gram either way. It might be as much as a gram. I didn't actually work that out, but I can tell you if it's worth doing or not. But there is differences between the relative strengths of all the acids.